get started? Is there any other paper homework to be handed in? This is it? Email spreadsheets, any last minute email spreadsheets that are coming in right now? This is it? All right. What I want you to focus on, though, to prepare for the quiz is understanding how the variables, we get there, and the objective function, and the constraints from reading a story like this. You will probably have at least 2 of these at your next quiz. Where if you're given the story, you're asked, identify the variables, write the objective function, write the constraints. We started this one last week, so I'm just going to kind of, the first part's going to be review. Because I want everybody to kind of use their imagination. This is the key, I think, to be able to write these. Is using your imagination, trying to visualize you have to make these decisions, and it should come to you then what the decisions are, and then make those variables. And the picture I was trying to paint when I introduced this to you last week is where, and I always suggest to somebody when they want to start their own businesses, I always say, micro it, start small. Do it in your garage, do it in your basement, keep your job, don't take the risk of walking away from your job, don't go out and try to get $1 million loans just so you can set up and fail, because that's what most businesses do. Start out small. Spend as little as you can of your own money, or any money at all, and test out the theory and see if this is really could be as big as you think it can. Before you, because the defeat of spending a loan of $1 million that you're going to default on possibly, and renting a space for $10,000 a month that you're possibly going to default on, and all the troubles you're going to run into before you finally decide to go out of business and go bankrupt for the business, will discourage you from ever blossoming a new idea and chasing it. If you start off small and you eventually figure out, this may not be as big as I thought it was, you still have that inspiration. You haven't been knocked down completely, and you will come up with a better idea to then try out. And you would not have wasted a ton of things, and people will still lend you money when you finally find the one that is going to be big. It's taking the money before you know it's big that leads to the failure, that leads to, it'll be years before you can try it again because no one wants to lend you money. So in this case, I try to get you to imagine that you somehow on eBay or Craigslist found these little containers that are real, in real life, that dump grade into a conveyor belt of a bag or some container going by. And there's a little sensor. And as the container gets there, the belt stops, and the next bag is already at the second one, the next bag's at the third one, the next one's at the fourth one. And for a few seconds, they go zip, and you have set each of those 4 at exactly the calibration needed for the exact amount to dump into that bag. Now the story says every one of those pet food bags you're going to have a ½ pound in it, 8 ounces, which is a ½ pound. So when you look at all this data, and it's all based per pound, your instincts are going to say, well, we'll only need a ½ pound, and you're going to want to cut all these numbers in half. That's a ton of work, and it may lead you to the right answer, but it's so much easier just to say, okay, these are all in pounds, write about just as you see them, but make the constraint that determines how much goes in each bag equal to a ½ pound, and that takes care of all of it for you. Let me explain. Each variable, we'll call this x1, x2, x3, x4. This is the decision that has to be made. What do I calibrate these to so they dump the exact right amount in, the other one, the third, the fourth, and when they're all 4 done, whatever amount they dumped in adds up to exactly a ½ pound. You get it? So think about it. 4 numbers that will add up to a ½ pound, 0.5. Maybe it's like a tenth of a pound, plus maybe let's go with 2/10 of a pound. So now I'm at 3/10, maybe another tenth and another tenth. And you may have to set these at 1/10 of a pound, 2/10 of a pound, 1/10, whatever order I do it, 1/10. That's where you use your imagination. And what I just did there is I have a good idea what the answer should be, and I will know if I'm doing this right or not when I try to solve it. Because I imagine, okay, if it's got to be a ½ pound, and when it gets to the end, that's what I'm setting these 4 at, so that they dump in just the right amount. You look at this, Tell me which grain you hope that this calculates out to. When I say hope, because your whole plan is to make money. This is your retirement, and you think it's going to be fun, even though it's going to be harder work than your job. All right? And your hope, because you want to make as much money as possible, is that most of which grain ends up getting calculated into that bag of pet food. That's right. Exactly. Everybody knows what I was leading to then, because it's the least expensive, right? But you got to meet these requirements. And your goal really is to make a better pet food at a lower price. The whole thing that drove you is you've been buying pet food for your pet, and you're saying, God, this is a lot of money. There's got to be a less expensive way to do this. I bet I could compete against them and have my own pet food, and it'll be so much less expensive and better. Maybe I can make it better even at a lower price. And that was your whole inspiration to even start doing this. And you spent maybe a couple $100 on these things you found on eBay. You got it all set up. You don't even have a conveyor belt. You're just moving it yourself by hand to see if the sensors are working. All right? You hope a lot of flour goes in there to keep your costs down. So, if the objective function is to keep costs as low as possible, and you have 4 grains that you've set at 4 variables, help me write the objective function, max or min? Min, very good. Now, I got to turn my variables, which is how much goes into each bag, into how much we're spending in each bag. What do I do with X1? Times the price, 0.75, exactly. 0.75 X1 plus 0.90 X2 plus 0.80 X3 plus 0.70 X4. There's my objective function. Exactly. Now, I'm jumping to the half-pound bag in just a minute because I know I stated, but I want to go to these government requirements that we found out about, which we'll call limitations in a way. And it says, however you mix that half-pound bag, you have to have a minimum amount of 6 units of vitamin C. You look up here and you go, which one provides vitamin C? How fortunate is this? Look how much vitamin C with grade 4, which is our less expensive. This is not a bad thing. But you got to write this out in constraint. First of all, we know we need 6 units put in there out of the 4 grains as they get dumped. They got to add up to 6 units. Less than equal to 6, greater than equal to 6. Greater than. So at least 6 units, exactly. At least 6 units, and this is our vitamin C. Okay? I now have to take the variables x1, x2, x3, x4, turn them into the amount of vitamin C based on the amount that's being dumped into each bag. Tell me the number with x1. 9. 9 times x1 plus x2. No. 16. You got to go with vitamin C. 16 x2. You jumped over the protein. You realize that? Okay, just making sure. Plus 8 x3 plus 10 x4 less than equal to 6. There's my vitamin C. So you know where this is going. Because the next one's going to be 5 units of protein. And you know it's going to be greater than equal to 5 for our protein. And you know all 4 variables need to be changed into the amount of protein they would provide if they're dumped into the bag. So give me the numbers just so I know we're on the same page that I would use with x1 and x2. 12 and 10, exactly, another 10 and an 8, straight down the protein. 12 times x1 plus 10 times x2 plus 10 times x3. And you can leave, 8 times x4, greater than equal to 5. Iron. We have to make sure that bag, which could be taken off the shelf at any time, at any place that we have a contract with that we're providing this on their shelves, and it could be inspected. They'll probably use 30 of them. Most statistics is always based on at least 30. And they'll randomly pick 30 of your dog food off the shelf, and they're going to check to see if you have at least 6 units of vitamin C, 5 units of protein, 5 units of iron. And if you don't, I don't know what the rule is. You may get one warning, but if you don't on the second catch, you probably, all of it has to come off the shelf right then. And you have to fix the problem. You have to restock, proving that you're meeting these requirements, which will be very expensive. So you make sure, and when you do a run, and you just did 3,000 bags of food, you grab 30 out of that bin, because you stop the machines, and they're all calibrated still correctly, but you grab 30, and you check that you're meeting the requirements, and that it weighs exactly half a pound. And if it doesn't, if you check 30, and you're really close to the mean within one standard deviation, you can make the assumption that all those 2,000 men are going to be, and if you got a contract with a big retailer, when your truck arrives to deliver, before that truck leaves, they're grabbing 30 and they're making sure also. It happens at a lot of big retailers. So just check it, because the amount it will cost, if it doesn't check out, is way more than the cost to check 30 before it leaves. All right, so we got all that. Now, an 8-ounce bag. Are you ready? By telling Excel that however much, this variable represents how much of grain 1, plus however much of grain 2, and however much of grain 3 should go into that half pound, and however much of grain 4, now this is one of the few equals. Since everything's in pounds, you tell it that they need to add up to a half a pound. That solves all the half pound versus pound numbers from that point on. That's how you solve it. The half is the amount that's going into the bag in pounds. The variables represent how much of a pound is going to be dumped into each bag. And that solves it, half a pound from that point on. All right, and I think that's all our limitations. Let me take a look. 4 variables, x 1, 2, 3, 4, minimize, 75 cents, 90 cents, 80 cents, 70 cents. Then, what do we got next? Half a pound bag. Greater than or equal to 6 units of vitamin C, greater than or equal to 5 units of protein, 5 units of iron. We know our variables are not negative. The quiz is then, there'll be another problem on the quiz. You're going to see an output just like this, and you're going to be asked, what am I setting the first grain container, what am I calibrating it at, and how much of it will dump into that first bag? Everybody hear that? How much? What am I calibrating it at? Point what? Almost point zero. You're right. You look at 0.099. Just less than a tenth of a pound. I'm setting this one at this thing has so many little goes 3 to 4 digits to the right of the decimal. So you can be exact. 0.099. This next one's set at 0.213. 0.088. 0.099. You add them up, they'll add up to exactly 0.5. And this is, and what is going to cost for what's being put into that bag, not the bag itself and the printing of your logo, the grain that's in there. You already know you're selling these for about $4.50 a piece to beat the competitor. And you, depending on your overhead and your distribution and your bag and everything, but as far as the goods inside, are you making a profit? Matter of fact, because the cost for the stuff inside is going to be how much? 40 cents. Like 40.6 cents, almost 41 cents. Everybody see it? Objective function value. That's where you would look to answer that question. So you're going to be asked probably how much, one of the variables, so to see that you can look at the right variable and give the answer just like the homework. And you're going to be asked a question probably where you've got to compare the objective function value so you know that that's what's being asked about. Like, for example, if you're selling these for $4.50 a piece, is the cost of the goods inside the bag significantly less so that you most likely will make a profit? And the answer is going to be yes, because the cost going in the bag is only 40.6 cents. That's a significant gain. Don't forget there's overhead and all the other stuff, but usually the cost of the stuff inside, if it's less than 25% of the total cost involved or the price you're about to receive, you're probably going to make a profit. All right, let's do another one. It's going to get harder. What you're about to see is for my finance majors, raise your hand if you're a finance major. I know the camera can't see it. There's a lot of finance majors in here. This is going to look hard, but if you're a finance major, you better embrace this because this is real. Portfolio selections at brokerages or finance companies are method is used a lot to meet the requirements of the client. Whether it be, hey, we don't want so much in this kind of investment, or we don't want this much in this kind of investment. You know, we only want to take this much risk, using risk index numbers, estimates of what the investment could make based on past performance. All of these variables involved. So that's where we're going. It's going to look hard first. Before I read it to you, though, I want to kind of introduce you to the different options so you can see. I'm going to paint a picture. Because this is the key to figuring out the variables. You've got to try to imagine this is real. That you're the person who has to come up with how this money's invested. $20 million, this client. You've been assigned this $20 million investment project. And you've got to come up with how it's going to be invested based on the client's requirements. And this is a real test because the client has some very odd requirements. One of the requirements is that they only want you to do this for 4 months, to set this up for 4 months. Don't get me wrong, some of the investments will continue after the 4 months, but as far as the decisions to be made, 4 months. And each month, there's decisions to be made. Here's the deal. In the first month, they only want you to use 3 options. Either, what's the first one called? Government bond. There's either the government bond option, the construction loan investment option, or, what do we call this? I call it cash, but it's called liquid account. It'd be like a money market account. That's like a savings account at a brokerage instead of a bank or credit union equivalent. Now, the deal is with, if you have money in this cash, is that you can do anything with it at the end of the first 30 days. You can reinvest into another 30 days. But this investment's about 30 days long. So if you put money in there in the first month, it's going to mature. And in month 2, that money that's maturing out of here, you've got to make a decision on what to do with it for month 2. And if any of it went into the liquid or cash account in month 2, it's going to mature at the end of month 2, and you've got to make a decision what to do in month 3 and month 4, depending on. This whole thing is about figuring out what matures at the end of every month, so you know how much has to be reinvested. That's the tough part about this. That's how you got to look at it. And here's the other part. Each one of these 3 options are the same 3 options available every one of the 4 months. But treat them like they're all absolutely different decisions. Like on the key and the locks, there's knob and plate you're making, but that's a completely different decision compared to knob and plate you're buying from the contractor. 2 different variables. They're 2 different decisions. So how many decisions do you think you have here? If you have not looked forward on the PowerPoint, somebody hasn't looked forward, how many decisions do you think you have?
How many months is it?
4 months. 12. You have the same 3 decisions every month for 4 months. So you have 12 decisions. So what I'm going to do, this is the government bond 1, 2, 3, 4. So I don't have to make up a whole bunch of variables. Those 4 are right there. I'm just using a 1, 2, 3, 4 based on the month. I'm going to do the same with the construction loan investment, 1, 2, 3, 4, and the cash investment, 1, 2, 3, 4. There's my 12 variables, 4 times 3. All right, let's start with month 1. Client walked in. How much did I say they gave it to you? You have to make a decision on it. 20 million. We're going to write a constraint based on 20 million. Whatever your decisions are for the first month, and there's only 3 decisions available, and that's what you're deciding, how much goes into each one. So I'm going to go with GB1 plus CL1 plus, I don't want to call that cash, what can I call it? I'm going to use a big C, 1. What goes here? However much you are going to recommend goes into the government bond investment, however much you're recommending going into the construction loan investment, and however much you're recommending going to cash, has to be something 20 million. Can you invest less than the client told you? You can. What are you going to do with the rest? But that's an investment. So even if you put it in there, it's invested. That's one of the 3 decisions. So it has to be equal because every penny has to be invested, because even if you're not investing in these 2, everything else goes in here. Which is what most investors do. They'll put it in the money market, liquid account, waiting for the opportunity to invest it in something that maybe took a dip or something like that. So this is one of those few equals again. Every penny has to be invested in the first round. Very easy to figure out how much is going to be available. All right, let's get to the story because I'm jumping ahead. Here we go. This company, this savings investment company, has 20 million available for investing for the next 4 months. The client's asking you to maximize the interest earned. We got to talk about the interest earned on each of these investment opportunities. Remember that statement? There are 4-month periods, and you have and the client said at the end of the 4 months, so think about this, at the end of the 4 months, whatever is maturing, at the end of the 4th month, whatever is maturing, think about what investments would be finishing when you look at the length of times on these, has to add up to at least $10 million, because they committed to a construction project, so that $10 million is going to be taken away at the end of the 4th month. So they have to have enough investments maturing at the end of the 4th month. My question for you, is there a cash investment that will be maturing at the end of the 4th month? And if so, which variable is that? Think about it. At the end of month 1, which variable is maturing out of these? C1. At the end of month 4, which one's maturing? C4 is one of the variables that you are going to do something about that $10 million when you write that constraint. It's whatever matures at the end of that 4th month needs to be at least $10 million, because we have to send it back over to them so they can get in that construction project. Think of that constraint. Now, here's the deal with these investments on time and interest. Any money that's put into a government bond interest, whether you put it in month 1, 2, 3, or 4, it must stay there for 2 months. You're committed. So think about that. If we put money in GB1, at the end of month 1, do we need to consider that to be reinvested? Because it won't mature yet. But when we start making decisions for month 3, G1 is one of the ones maturing that we're going to have to make a decision on for month 3. I haven't given away why I keep saying this, figuring out what matures, but the light will turn on in a minute, because this is all coming to a point to where you have to come up with what variables are maturing every month. That's what this whole thing's going to be, is what's maturing. Okay, now we're on month 2. What's maturing? Now we're on month 3. What's maturing? Now we're on month 4. What's maturing? And now that we're finishing month 4, we need $10 million. What's maturing? Get it? And that's how you write these constraints. If you go with a construction loan, it's a 3-month commitment. So CL1 will not be maturing at the end of month 1, will not be maturing at the end of month 2. CL1 is not maturing until the end of month 3. My question for you is, what happens if there's money in CL4? And we get to the end of month 4. What's happening to that money? Is it maturing? No, it's got to stay there for 3 months. In the calculation to make sure you have $10 million, CL4 would not be involved in that constraint at all, because there's no way that's maturing at the end of that 4th month. That money stays, even though your job is done, that money doesn't go back to the client until that finally matures, which is fine. And then the last one's for 30 days. Here's the interest for the time period that you've committed to. If you commit to a government bond, over the 2 months you're making 2%. Which, when you use these percentages, you've got to make them decimals, because the variables are how much to invest. You need to multiply times the percentage, the decimal form of the percentage, not just a whole number. So don't use the number 2, 0.02 when we get to that. And if you commit to 3 months on a construction loan investment, you're going to get 6% at the end of the 3 months. Unbelievably great investments. And if you commit to money for 30 days here, you're going to get 3/4 of 1% interest for the 30 days. Help me on a decimal, 0.075. Very good. So when we get to that one, that's the decimal for that. Okay. Are you ready? We'll start with the 20 million. Here's all the variables used in deciding how to invest the 20 million in the first month. The second month, you ready? We have decisions to make. GB2 plus CL2 plus C2, and these aren't the variables used in this problem. I'm making these up on the fly, so I hope you guys remember what they stand for. This is the decisions to be made in month 2 where the money should be invested. And it's equal to however much money is there to make a decision on to be invested. And you already told me, if we went in month 1 and put money in here, There is no decision to be made in month 2 about that because it won't mature. That's where the right side of all these constraints come in. This is whatever's maturing, the amount was put in plus the interest is going to earn. And you add up all the ones that are maturing and the amounts that were put in plus the interest they earn, all added together. And that's the decision that has to be made. And here's the decisions you have to make with that. So let's start with this liquid account. If we had some money in there in the first month, and now we're going on month 2, is there possibly money maturing that we have to make a decision on?
Yes.
There is. And that's, we're calling that C1, right? C1, but if I just use C1, it's going to be whatever amount I had put in there. We got to multiply C1 by something to say, hey, it's not just the amount I put in, it's the amount I put in plus the interest it earned. You're going to multiply it by 1 point and the interest. So you're multiplying it saying, I want to know what it adds up to. Itself plus the interest. You ready? This has to be multiplied by 1.0075. Put a C1 there times 1.0075. Pretend you put $1 million in there on your calculator. You'll see when you multiply it times 1 itself plus 0.0075, it will come back 1 million plus 3/4 of 1% interest. And that's what it will turn into at the end of those first month. And you have to make a decision now on that money. No matter what you put in there, it will turn into itself plus the interest it earned, and that you have to make a decision on. Next, construction loan 1, we probably put some money in there in month 1. Do we need to include this on the right side of this constraint? Because it's not maturing. GB, government bond 1, we probably put some money in there in month 1. We're making a decision about month 2. Is that on the right-hand side of this constraint? No, because it's not maturing. Nothing in month 1 is maturing except for that. This constraint's done. Month 2 is done. Month 3 gets a little harder. You ready? Month 3, what decisions do we have? Well, there's the same old decision, GB3. Construction, loan, investment 3. The cash investment 3 equals, oh, almost forgot. Don't forget, when you write a constraint like the one we had just written, it's not finished until you get all variables to the left side. One side, how's that? I know some people want to take it to the right. All variables on one side, nothing but a number, whether it's 0 or a number, on the other side. I got to get this 1.0075 C1 from the right side to the left. I'm subtracting it. So I'm subtracting it over here. What's going to be left on the right side? 0. Very good. GB2 stays the same. CL2 stays the same. But, again, I got to make sure I get this. But this turns into C2 minus 1.0075 C1 equals 0. By subtracting on both sides, and it's a completely different variable, it's not the same as C2, so you don't combine these. It's a different variable, it's a different decision. You add it to the left side by subtracting on both sides, so subtract it, now you're equal 0. Okay, back to month 3. Wait for you guys.
It doesn't matter where we put negative 1.07.
Yeah, you can put it in between here, here, here. I just added it to the end here.
Okay.
I'm going to put a little arrow where I'm putting it right there, before the equal sign, obviously. Same thing's going to happen here, but we first got to figure out the right side. The right side is anything that matures, and I know we put more money into that cash too, probably. So I got 1.0075 C2 on the right side. Is there anything else maturing? The first month's what? That's right, the government bond. GB1 that we did in the first month, and we didn't put, and then in the second month we didn't put it on the right side because it wasn't maturing. But month 3, that government bond for month 1's maturing. So plus, what number do I put in front of GB1 though? Is there a 1 point? Yes or no? 1 point what? 0.02. 2%. It's going to earn 2% over those 2 months. 1.02 G, what is it? GB1. Because that's maturing. Is there anything else maturing other than month two's cash account, that's 30 days, and month one's government bond account, that was for 2 months. What about the construction loan from month one? It's not maturing because it's got to be in no longer? Okay. And nothing else then? Go ahead.
What about the interest that you earned from C1?
The interest from C1 plus itself got subtracted from all of these to equal 0 because this was the amount that we had to reinvest into these. It all gets reinvested in there. These have to add up to all of that money. That's why it gets subtracted to get to 0. Because we have it on the right side. We have to now get these to the left side. Everything we're investing in here has to be everything that's maturing because that's the only cash available to reinvest. And we don't know how much that's going to be because we don't know how much was put in, but we know however much was put in, when it's multiplied by itself plus that interest, it's going to turn out to be whatever we had put in plus the interest. And now we're going to move it over here. Subtract 1.0075 C2 minus 1.02 GB1 equals 0. So if we subtracted these on both sides, you can place this in the front, you can place it in between the equal sign, the C, wherever you want to place it. But it's got to get to the left side, and now they're minuses. All right, one more month. Month 4, same 3 decisions. GB4 plus CL4 plus C4 equals. There's our 3 decisions, but we have to figure out what cash is maturing that we're going to have to reinvest in month 4. Let's start with month 3's cash account is only 30 days. We know that matures every month. So I'm going to put 1.0075 cash account number 3 from the 3rd month maturing. And then, is there any government bond investments we got into maybe 2 months ago that's now maturing? And what is it, if it is? GB what? 2. The one we got in month 2 is now maturing. Month 1 matured here, so now month 2 is maturing. So I'm now adding 1.02, the 2% interest plus itself, GB2, because it's maturing. And now, is there a construction loan investment maturing? CL1? No, CL1. If we happen to put any money in back in month 1 in that construction loan investment, it is a 3-month commitment. It went through 1, it went through 2, it went through 3. It's now maturing, and it's part of the decision. So we have now, this is, what's the interest rate on that? 6%? 1.06. Construction loan 1. Is there anything else maturing? So there's only government bond investment number from month 2. There's only construction loan investment from month 1. And of course our cash investment that every single month from month 3 is the one thing there. That seems to be the only thing maturing. So we would subtract each of these 3, get them over to the other side, make it equal to 0. Now the big one is making sure the company has $10 million at the end of month 4. This was the beginning of month 4. At the end of month 4, or really we'll call it month 5, we have to make sure there's $10 million. Less than equal, greater than equal $10 million. But the greater than. We got to make sure there's at least $10 million for them to go into their construction project. If we don't make sure there's $10 million maturing at the end of that 4th month, we probably have to lend them our money interest-free because of the mistake. If we guarantee them, hey, if you let us have this deal, we'll try to give you as much interest as possible, which is our objective function here in a minute. And we're going to make sure there's $10 million available maturing at the end of the 4th month so you can go into the construction project. On the left side is going to be any variables that are maturing at the end of the 4th month, and the amounts are going to be themselves time, the variable times 1 point, whatever the interest they'll earn at the end of their time. Obviously, there's a cash account every month maturing. So I'm going to do the 1.075. Ready? I'll do it right here. 1.0075 cash account number 4 will be finishing at the end of month 4. But is there a government bond investment that may be maturing at the end of month 4? And it's GB, which one? Right here, 2 and 3. I mean, look, which one did we put back here? When we were at the beginning of month 4. So which one probably is going to mature here? 3. So, and what's the interest rate on that one? 2%? 1.02, government bond number 3. So it went through month 3, it goes through month 4, it's maturing right at the time, and we gotta make sure there's 10 million. And then, if there's a cash and there's a government bond, there's probably gonna be a construction loan investment, 1.06. Construction loan, what number is maturing at the end of month 4? 2. Month 1 matured at the beginning of month 4, so at the beginning of month 5 would be construction loan 2. Those 3 have to be greater than 10 million, and that's how we make sure our clients are going to get the 10 million for the project they are going into. You ready? Here we go. Oh, I almost forgot. These clients pulled a fast one on us and said, look, whatever money you're putting into government bonds along the way, if you add up all the money in government bonds at any time, it cannot be more than $8 million. If you add up any of the money you have in construction loan investments at any time, it cannot be over $8 million. Uh-oh, that's putting locks on us, that's putting handcuffs on. You ready? So, every month, we have to check that we are not investing over $8 million on either of those 2 possible options. I'm running out of space, but here we go. What are we doing? Here we go. In month 1, government bond investments 1 has to be less than or equal to $8 million. In month 2, government bond investments 2, but because government bond investment 1 is not maturing, in month 2, there's going to be money still in government bond investment 1, and when added together, they can't go over $8 million. So help me out with month 3 that you see the logic here. With month 3, again, can't go over $8 million, but what's over here? What would be still invested in government bonds when we get to month 3? GB what? 2, GB2, and 3. Notice we're using 2 and 3 and not 1, like we did here and here, because 1 is finally matured. That money wouldn't be in government bond investment anymore. But we could be putting more in it in month 3, and month 2 still has money in it. If we ended up putting any in, they, when added together at the end of month 3, cannot be over $8 million. Help me with month 4. $8 million. GB what? 3 plus GB 4. Because 2 will have matured. 3, there could still be money in it. We're making a decision to put money in or not in month 4, but we can't go over $8 million. Real quick, I want to make sure you get this. If we put $8 million in right away in month 1, $8 million's in there. The Excel spreadsheet goes to month 2, calculates how much is it going to put in, possibly in government bond investments for month 2. Yeah, there's no way it could put, if we put $8 million in right away, in month 2, it is not an option to put more in. Because we got $8 million plus whatever you want to put in here is already going to take us above $8 million. Same with this month. Okay, we didn't get the chance to put any in month 2, so that's a 0. But month 3, we could put money in, and we may put $8 million in, because we can put up to $8 million, because the one we put in for month 1 is now mature. All right, the other statement is the construction loan investment can't go over $8 million at any time. Almost just like what we just did, but a little trickier because it has a different expiration. Was that $8 million also? Or $10 million? $8 million? There we go. Less than equal $8 million. Less than equal $8 million. Let's just do the first one, less than equal $8 million. There's 4 months. We're going to check it at the end of every month. In month 1, we know that's construction loan 1. In month 2, what variable should be used to represent all the money that could be in construction loans? 1 and what? 2. CL1 would still have money in it because it's there in the second month. Plus, we could be putting more in it. Now, is it only 2 and 3 in the third month? CL2 and CL3? No. What else? That's right, because this lasts for 3 months. So the money we put in the first month would still be there, CL1. Plus, if we ended up putting any more in the second month, still there, CL2. Plus now, if we have the chance to put more in month 3, and we might, we can't go over 8 million. Now month 4 is construction loan investment 1 still possibly have money in it? No. So it's gone. But CL2, construction loan 3, construction loan 4 are the 3 variables there. So these are only using 2 variables, but these are using 3 because they last 3 months. You get it? It's all on the PowerPoint, just to review. G, 1, 2, 3, 4. C, 1, 2, 3, 4. L, there's our variables. We have to do the objective ones. Every one of the G's we multiply times the interest they're going to earn if we happen to put money in it times 2%. All of the construction loan investments, if we happen to put money in those, times 6%. And every one of those liquid accounts times their 0.75%. When the decision's made how much is going into every one of these 4 months of options, times the percentages, that's what we're trying to get for the client. The highest amount of interest possible. That's the goal. But they put handcuffs on us. We gotta stay within 8 million. We gotta stay in with 8 million on the summer investment. What was the other handcuff? And we only have 22 million to start with. I think that's about it. We have to complain at all. Here's our 20 million to start with. Only the month 1 variables are being used because those are the only options we have in month 1. Here's month 2. We have to make 3 decisions. And what's maturing? Just that liquid account for month 1. And now we subtract it on both sides. In month 3, here's our 3 decisions again. What's maturing? The liquid account matures every month. But now finally that month 1 government bond's maturing. We subtract them on both sides. Look at, they're all equal signs. Month 4, here's our 3 options. There's 3 things maturing this time. Subtract them on both sides. Here, making sure that we get that 10 million at the end of month 4 available for the clients. Here's everything that's maturing plus their interest. Did I put interest on when we did 10 million? I think I put interest. No, that's there. Plus their interest, got to accumulate to at least 2 million or 10 million. Look at the 3 variables times their interest. All right, think about the variables. You've been given an output. The output says, what's the maximum amount of interest based on these limitations that you, here's our limitations, sorry. Here's our other limitations. What's the amount of interest, the most we could get for this client with the restrictions they've given us on how to invest it? How much money are we going to earn in 4 months for them? 1,429,213.80, almost 80 cents. In 4 months, because those investments are unbelievable. 2% in 1 month is unheard of. How much are we putting in the government bond investment right away in that first month? That's right, the max, 8 million. That's why you should see a 0 for government bond the second month, because there's no way we could go over the 8 million. How much are we putting in the construction loans right away? Where's construction loan 1? The total, the most we could, and that's why we can't put any money in the second month or the third month until that matures. So you should see a 0 for C2 and C3 because that's got to mature before we can put any more in there, because the most you can have in there at any one time is 8 million. You can see the liquid accounts. We started with only 4 million in there, but then it matured, and we had that much that we reinvested right into here by the looks of it, because these 2, we couldn't add any more to it in the second month. We were already at the max. Month 3, all right? Month 4, remember the variables that at the end of month 4, if you look at them, they should add up after you multiply them times their interest on top of it to more than 10 million, which would be looking at, where's the 10 million? C2, whatever you see where C2 is, multiply times 1.06. CG3, multiply times 1.02, and L4 times 1.0075. If the question said, show the math to verify there's going to be more than $10 million there for our clients at the end of the 4th month. That's how you would do it right there. And you go to those 3 variables. I can't remember what they were already, but C2, was C2 one of them? Yeah. So that's easy, 0 times whatever. G3 was the other one? G3, that's going to be multiplied times 1.02 though. And L4, if you add that times 1.0075, G3 times 1.02 and then 0, it's probably going to add up to either exactly 10 million or for sure over, but it will not be less. Or else we may not error. All right. I think we have enough. We're ready to do the in-class assignment. You are supposed to be at the point now where you can read these problems, identify the variables, not as hard as this. And in fact, the one you're about to see is in my opinion, so easy that this is all about not working together for the first time on an in-class assignment. You're doing it on your own because I need to know if you are going to be ready for this next quiz. I need to know if you're still stumbling over forming linear programming models. Don't forget, any problem that says forming linear programming models means identify the variables, your objective function, and all the constraints. Don't forget to identify your variables on this.